Okay, let's go. Okay, so you know that when I come up to you, I like to talk a little bit about what's happening in the industry. I'm letting Paul and Giorgio talk more about our products and what we do, but I like to give some perspective about why we do what we do and what we see happening in the world. And as usual, you're very welcome to make comments or disagree with me. I love conversation. So today I'm going to start with an article that I noticed from Andreessen Horowitz. Andreessen Horowitz is one of the most famous VC and definitely the latest of the famous venture capitalists in the Silicon Valley. Came about with the meeting of Andreessen with Mr. Horowitz. And they published a couple of weeks ago a blog post called The Cost of Cloud, a $1 trillion paradox. And in this post, they say things that I've been saying for 5 years, except that if it's Jerome Lecat saying it, not everyone believes me. And suddenly when it's Andreessen Horowitz saying exactly the same thing, I see a lot of traction and people asking me about this article and what I think about it. And they do a really thorough analysis on how much it costs to have a large-scale infrastructure in the cloud. People like Datadog, for example, who have most of their operation on AWS. And, it's about 30%. They have a 70%, they have a 30% cost on what they do from AWS. So 30% of their revenue is spent on AWS. Or people like Box or Dropbox, Netflix, people who have large infrastructure. And so they do a thorough analysis of a bunch of public companies where they can have the data. And they say what's obvious, that when you start a project, starting in the cloud is really the most agile and the cheapest method. But then when your project becomes big or very big, well, there's a point at which you have a little bit less growth in your project, and someone's going to start looking at what's your profitability. You know the word profitability? I know this is a word that no one speaks about in the startup world. I personally think that this is very important. At the end of the day, there's this concept of a shareholder value and returning value to all stakeholders, our customers, obviously, our partners, our employees, society at large, technology, but also the shareholders. And so there's a point at which you want to be profitable, you're making less growth. At this point, you start turning to cost. And, something else that's obvious, AWS is operating with essentially 30% gross margin, which means that they mark up the cost of their service by at least 30%. And we see that in our customers. We often actually compete in some way against AWS for large projects where customers will hesitate between putting a large project on AWS or Azure or Google, more often AWS, or deploying an infrastructure with Scality. And every time we can show that deploying an infrastructure with Scality is going to be cheaper, typically 30% to 50% cheaper, depending on what you do. So this is what Andreessen Horowitz, studies precisely. And they come up with that conclusion that, again, we've been saying for about 5 years. You're crazy if you don't start in the cloud. You're crazy if you stay on it, meaning you're crazy if you stay on it past a certain size. So what does that mean? So first of all, I'd like to go back to how big is cloud? So before I show the next slide, I'm going to be a little bit interactive. How much would you say is all of cloud services, everything, PaaS, SaaS, IaaS, business process as a service, backup as a service, you put everything together. How much is this as a percentage of total ICT spending in the world? Who wants to risk a number?
It's about 1.2 trillion.
What is 1.2 trillion?
The total IT spending in the world today.
Okay, so I said ICT, I included telecom.
Oh, the
I don't know who
2.1.
spoke. Unfortunately, I don't see who spoke.
2.1 trillion.
I was going to
2.1.
guess 5%, and
Yeah.
looks like I'm about right then.
5%?
Hmm.
The real answer is nobody knows because no one's ever managed to count it all.
Okay, Tony, I will grant you that. But
Yeah.
I went to Gartner and I asked, okay, Gartner, how much do you think it is? Okay, and I can tell you that for the ICT spending, I have found various estimates from 4 to 5 trillion. Again, that includes telecom. I don't know who said 1.2 for just IT. It's probably about right. And cloud is 8% of ICT, and I consider it's relevant to look at the whole ICT. It's growing. It's growing 1.3 point per year, so it's going to be 9.3% next year. It's still really, really small, actually, and it's growing fast, but it's actually not that fast. And by the way, the ICT spending overall is also growing a little bit slowly, but a few percent a year. If we took just infrastructure as a service itself, just IaaS, it's only a quarter of that number. It's only 2%, and not growing fast. So, I mean, this cloud phenomenon is really very important, but it's not the whole picture. And more we see that as projects are becoming bigger in the cloud, we are hearing about customers who say, okay, well, I've started this project in the cloud. It was really great, but now it's becoming big. Now I need to look at my cost, and I'm considering bringing back into a data center that I control, essentially for cost reason. So while I have heard several years ago, cloud is cheaper, cloud is cheaper, cloud is cheaper, I have seen large enterprise moving to the public cloud because it's cheaper. Now I see large enterprise moving back from public cloud to private cloud because it's cheaper. So we need to qualify this cheaper thing. And there are many other reasons to go to the public cloud. It's just that when you have a large scale project, cost is not the primary reason. Agility is definitely a really good reason. I mean, definitely currently a public cloud infrastructure, especially with the wealth of services that you can find, especially on AWS and Azure, is a good reason to go to cloud. But that's completely separate from cost. Okay, it's a totally different reason. So a few myths and realities. So first of all, what is cloud? You know, I really like the initial definition of Gartner on cloud. They defined it as a style of computing. By the way, I couldn't find anymore a general definition of cloud by Gartner. They now have separate definition for public cloud and private cloud. And these definitions are not as generic as the initial definition they had put up in 2008 or 9. My take on what cloud is that it's a style of computing that's characterized by software-defined distributed infrastructure with a high degree of automation. And that's really what it's about. And whether it's public or private is really, it's a detail. I mean, that's a delivery mechanism. And, you know, really in IT, there's been this pendulum between outsourcing and insourcing ever since IT started. Obviously, IT started with the mainframes about 70 years ago. And that was all outsourcing because not everyone could have a mainframe. So you would buy Cycle on a mainframe. And then there was insourcing. And then it's been swinging. But
Jerome, may I?
Bertrand, yes.
Yes, yeah, because for the moment, we see the client side, the enterprise side. That means that the way of cost and so on. But cloud has also, our public cloud has also another side. It's for all the industry providers to keep certain promises. For example, resources with quite infinite resources, meaning that I can provide you everything that you need, you, enterprise and customers. And another point is also that the way, and you say it for the companies, that is a scalability. Okay, but how to do this large project or this all projects that there are in the cloud, in their own data centers, do they have even enough resources, people, money, experience, skills to do it? Certainly not.
The cloud looks infinite when you're small. When we did our prototype to show 1 terabit a second in Azure, and that's something we announced in September, October last year, you might have seen it. We ran into all sorts of limitations where we had to call the Azure team and get special rights. Every time we're trying to run a large-scale experiment, whether in AWS or in Azure, we're bumping into limitations. So it's not infinite for everybody. If you're big, it's not infinite anymore. Okay, they can free up resources, but it's not that. When you're a small business, it's infinite. I fully agree with you, Bertrand. I'm talking here about larger projects. For larger projects, it's not completely infinite. The other thing is, if you are doing a larger project, some of our customers, they're spending 100 million or even $1 billion a year in IT. I'm repeating, some of our customers are spending 1 billion a year in IT. When you're spending $1 billion a year in IT, I mean, these are some of the largest banks in the world, and that's what they're spending. You actually can afford to have the teams to manage this. And the truth is, when you have projects that size, if you talk to JPMC, which is pretty, it really has hybrid cloud infrastructure. I mean, when you have projects of that size, even if you want to go full cloud, it's actually not that easy, because managing all the security framework that you know how to manage in an on-prem environment is just very different. It's not really harder, it's just totally different in the cloud. So you need to reinvent some of your skills.
Another question. You said you've got limitation with AWS and Azure. You ask them, do they provide you the resources or not?
Yes, they do. They do. I mean, provided you pay, but it's not infinite. I mean, they will. But
I don't say it's infinite. But when you ask for the resources, you have it, and you pay for it. That's all.
They will. Again, when you're a customer of that size, nowadays you can easily rent space in data centers. I mean, there's some very good PUE data centers out there for rental. I'm not suggesting that people are going to own their data centers. I don't think that this is, the best use of capital. What I'm suggesting is that cloud is not, at a certain size, cloud is not the cheapest option. And at a certain size, when you have, when you get to companies, traditional companies, they have 10%, 15%, 20% gross margin, you watch your cost. And the proportion of your IT cost as a total of revenue is growing, because every industry is transforming to be more digital. This is true all across the world, across all industries. So the piece of their total spend that is ICT is growing. And when you don't have that bigger gross margin, you watch your cost. And this is just mechanical. It's just going to happen. They will watch their cost, and cloud is not the cheapest option. At least that's what Andreessen Horowitz is saying, and this is what I believe. Now, I'd like to talk a little bit about the famous consumption model, okay? You pay as you use, okay? So I've looked at that, the more I look at it, and the more I'm convinced that this model really benefits the supplier more than the customer. You need the supplier to have a long-term view. But over time, if you can have a horizon that's bigger than 5 years, at the end of the day, it's indeed the supplier who gets more money. And that's why every supplier is moving to recurring revenue model or subscription model, because with a long time horizon beyond 5 years, as a supplier, you make more money. And by the way, Scality is doing this the same way as everyone else, because we figured the same thing. So this is going to stay. And I'm not sure that this is great news for customers overall. So, where do I take this? I love seeing that. That was in February this year, just a few months ago.
Sorry, Jerome, can I interrupt?
Yeah.
We've got some questions in the chat for you.
I don't see them, but yes, go ahead.
Yes. And there's rather a lot, actually. I was hoping that
Hold on. Let me see if I can see them.
someone from your team. So, first of all, Brian Betts said, maybe you could ask if there is another good definition for your very first question. But let's move on from that. We can circle back if we've got time later on. So Simon wants to know, is this an issue of IaaS versus PaaS? Cloud native design consuming PaaS is more economical than an IaaS lift and shift.
No, I don't think that this is that quite. I'm not sure I understand the question, but definitely, I definitely think that the whole world is going to move to cloud native design because this is what makes sense. It's more reliable and cheaper at the same time. So I personally have no doubt that the world's going to move to cloud native design. Just will take time. I think I have this 2 slides from now.
Okay, brilliant. Thank you.
To Chris, who says there's huge economy of scale of AWS operation. Again, any very large enterprise can achieve about 95% of these economies of scale. Once you're past a full data center and you're able to either rent or afford a data center that has a good, energy economics, you have most of the economies of scale at AWS. I put this at a few $100 million a year of spend of IT, which many entities have, many large enterprise and many entities in the public sector, many hospitals as well, actually.
One of the problems of the big clouds is that they're scaling so large that they now have costs that only they have.
Yeah, that's totally true. I don't know.
Right. So it's the difference between a bicycle, a car is a better version of a scaled up bicycle. And then a bus scales up pretty well. But then when you go to a train line to scale up to the next level, you never make a profit because train lines can never make a profit. And this is where the current public clouds are too cheap and they have to increase by 300 to 800% in the next 5 years to stay profitable.
So basically there's economies of scale up to a certain point, and then you have this economy of scale, and that's where they are. I fully agree with you.
Yeah.
Go ahead, Fred.
I don't have anything to add. I was just bringing attention to the questions on the chat.
So there's one question, Jerome, about what happens when you want to use resources that are only in the cloud, like Azure as a service with FPGA running inside of a cloud you may not have on-prem. Do you bounce in and out of a cloud? That was the question.
Do you have an opinion on Azure Catapult? I do not, but I do believe that the future of the world is cloud native in terms of architecture, because it's it's a software-defined distributed infrastructure with a high degree of automation. It provides reliability, better resource utilization, and lower cost. So I mean, I have no doubt that this is the future. I think also the future will be hybrid because the public cloud in the form of IaaS or PaaS makes a lot of sense in many cases, even if it's more expensive. And in many cases, as a CEO, you will not go for the cheapest option. You're going to go for the best option, and the best option may not be the cheapest option every time. So there's many things that you'll do in the cloud just because it's more efficient, and there's many things you'll do on-prem because it's cheaper.
Jerome, there is another angle here. I mean, a couple of years ago, we didn't have the technology to move workloads between the cloud and on premises. I mean, in most of cases, there was the problem of data gravity, or we didn't have Kubernetes ready for production. And now everybody is trying to figure out how to use Kubernetes to deploy a new application. The application becomes more portable, and there are a lot of solutions to move data seamlessly between the cloud and on-premises infrastructure. So you can start somewhere and move your stuff around when you need it, and it was not possible. So I think that some of this hybrid cloud is just common sense. I mean, you place your data and your application where they belong, and it all depends on how mission critical is the application, how much money you want to spend on it, you know, et cetera, et cetera, et cetera. I mean, so that's something that is evolving, like everything else we had in the in the IT. So there is a balance that we reach after some iterations.
I fully agree with you, and you know that we launched our Zenko technology a few years ago to help this movement, to help being able to move data from one cloud to the other. The reality is that today we see very few people actually doing it, because all these technologies, and even more than the technology, the know-how within enterprise is not yet where it needs to be. But I agree that with you that this is where things are going.
And the public clouds don't, the off-prem clouds don't want you doing hybrid. They want you locked into their proprietary platforms.
Yeah, and they do this.
They actively prevent it.
And they do this by offering you very clever services that are absolutely awesome and that you want to consume. And once you consume them, it's really hard to move to other systems. So indeed, I mean, they're not making it easy. You know, in Europe, this is the very reason why they have this Gaia X initiative to try to have interoperability protocols between cloud. I don't know how successful they will be, because the way the big public cloud defend themselves is not so much by preventing you to move, it's by offering you services that are so good that you don't want to move. And they're clever. I mean, they're doing this very well. Let me move on, otherwise I'm going to steal the time of my colleagues. So I just love this. This was 4 weeks apart. So first, I can't remember which one was first now. I do have January 21st. So first, Sabre announced a major partnership with Google. And then Amadeus, which is Sabre's main competitor, announced a similar partnership with Azure. So you might wonder, okay, well, who's the third one and who do they partner with? Well, I would say in some ways the third one is Expedia. And guess who Expedia is partnered with? AWS. Now, what are you doing if you're the fourth one in that industry? Well, you're locked out. And so this idea, the problem is that these big cloud companies, they actually go in many different businesses, and they're going to be competing with many of the potential customers of the public cloud. And not everyone's big enough as Sabre, Amadeus, or Expedia to form a partnership and to say, well, okay, what we could develop together, you're not going to give to my competitor and things like this. So there's a limit to this kind of thing. And because we're in a world that's transforming through the digital transformation, and because IT is becoming more and more one of the weapons for competition, that's going to change. So that's my prediction. First of all, I don't think we're going to see much change in the next 2 years, just because changes are slow. Changes of mentality are slow. People to really understand these things. We're going to continue seeing a race to the public cloud, essentially, even if this data starts coming out. We're going to see more and more data sovereignty pressure, which will push for localized offering. We've seen the formation of the Bleu initiative in France with Orange and Capgemini teaming to essentially deliver Azure services in France, operated by Orange and Capgemini, so that they can avoid the American Cloud Act. I mean, that's pretty smart. Google's and AWS are also negotiating similar contracts. So we're going to see more and more of that. And we're actually seeing our European customers being more and more demanding that anything we do for them be essentially hosted on European controlled data centers, where we're seeing this more and more. So that there's going to be that pressure. That pressure is going to come to the US also in some form. Everyone's going to want to have more sovereignty. I think that AWS and Azure will remain the dominant players for infrastructure, and Azure and Google for collaboration. I mean, they're so strong and such good technologies. It's very impressive. But I do think that in 5 years, we'll see the pendulum swinging again, and we'll see more software-defined infrastructure with widespread knowledge of Kubernetes. So this is, Enrico, this is where I see your prediction really coming true. And for me, the limitation is the maturity of the know-how around Kubernetes. Also, Edge will play a significant role. And you cannot make Edge to be 100% public cloud. So that's going to also contribute to more of a hybrid type of infrastructure. Large and mid-sized enterprise will realize that they need more control over their IT just to differentiate with their neighbors. If we're all using exactly the same IT services, and IT is a bigger part of the value chain, and we're all using, for example, the same AWS service, it's hard to differentiate. So they're going to look for other ways to differentiate. I do think that the subscription model is here to stay. And again, that's going to be by pressure of the vendors. And while all this is happening, data is growing and growing and growing. And the reason it's growing is because it's more valuable. And part of this is because it's driven by AI. Also because it's cheaper and cheaper to store huge amount of data. We see this with our customers. The hardware, the hard drive per capacity are becoming cheaper and cheaper. So, what's the consequence of that is that we see new workloads, especially around AI ML. We see more, more small IOs, more machine generated data. We see in our field of object storage, we see more demand for smaller capacity object store that are natural for cloud native app. I mean, that's the other thing. And there again, I agree with you, Enrico. Definitely, we're seeing more and more development and deployment of cloud native app. Flash media is a big thing. I mean, although I've seen this morning a prediction by a storage newsletter that the HDD market is going to continue growing in capacity for the next 5 years at 18% a year. We are seeing increasing use of flash media, including for large capacity. And we also see more demand for object storage. We've been at this business now for 10 years, and there's just more and more application that can target natively the S3 API. Initially, under the pressure of AWS S3, really, but more and more with demands of also on-prem deployment for the reason I've exposed earlier. So we're definitely seeing shifts in our business. And this is why we've created ARTESCA. Probably you've heard about it. It's a lightweight cloud-native enterprise-grade object storage. It's a radically new technology that we've developed for this cloud-native era. It's completely cloud-native in its design. It's lightweight because we are seeing demand, starting essentially at 10 terabyte. And we've really thought about how do we design a product that is both lightweight, simple to deploy, but also enterprise grade, because I do think that we're going to see more and more enterprise grade level, especially in reliability for all of this. This is where we see the world going, and I'll let Paul and Giorgio talk more about the product and show you a demo of something that's really awesome, I think. But we see these new workloads embracing object storage. We see more and more demand for localization. I think that's a trend that we'll see in the next 5 years develop. We are seeing new types of workflows where the data may be processed where it's generated, and that's really pretty much anywhere. There's definitely, we see more and more projects where we are being asked to deploy in 100 different places and then collate the data somewhere. And simplicity is really the name of the game. Both users, but also developers are asking for always more simplicity, and visibility and control is also a big thing. Okay, I'm going to stop there. I thank you very much for your questions.
Hi, everybody. Great to see you all. I have talked to a few of you in the last few weeks, but it's wonderful to reconnect. I'm going to take you down a level for about the next 10 minutes. and really focus on what we're seeing in the application space. I really want to focus on kind of the two categories you see here on the slide, AI, ML, and analytics, and tie that into what we're seeing in the object storage space and how we believe object storage can really add value here. I want to use this as kind of the setup to what we're going to show you next with Giorgio, where he is really going to show us a live demo of an application in this AI ML space running on object storage. So that's kind of the transition we wanted to give you. Indulge me while I provide kind of my 2 or 3 slides of perspective just to kind of paint the picture of this new world. Jerome did a great job of talking about cloud and cloud native, but I really just wanted to stand back and observe that just in the last, 30, 40 years, how many different models of computing have we all seen, right? I'm counting at least 5, and you might even say 6 or 7. Cloud native certainly seems to be happening. We think it's early days, but we are starting to see deployments of that. I actually have a slide where I'll talk about a large scale customer deployment in the analytics space using one of the big applications, which is Splunk. They are deploying on Kubernetes. So we're starting to see this happening at scale in mainstream type enterprises. So it's early days, but it is starting to come at us. I found this one interesting too, and I know that you guys track the market, so it's no surprise. Just the advancements in disk drives. I was with an object storage company 10, 11 years ago. Some of you may know I was with a company other than Scality. At the time, we had innovated in density, and what we were providing was 10 terabytes of raw capacity in 1U. Okay, so that means you would have needed a good half of a rack to get to 200 terabytes. I think you can see where this is going, right? Today, we work with our partner HPE all the time. They can give you over a petabyte in a 4U rack enclosure. So these kind of things really force us to rethink how we do things and how we optimize the world of object storage, especially as we deploy. We want to make sure that we're performant and reliable and keep the scale advantages. Jerome talked a lot about cloud, just to tie in edge. We are starting to see more edge deployments. This is both end user data at the edge, and that's kind of what we all know, right? It's the remote office collaboration type use cases, but also machine generated data. This is starting to happen more and more. Deployments where they have the need for camera capture and the edge, but it's in hundreds of locations. Those edge locations need to keep or persist the data maybe for a few weeks, but there's a strong need to retain it, filter it locally, and then consolidate it on some central site. We are starting to see more embedding of AI. There's a lot of predictions from IDC about how many applications will embed AI, and I think that's one of the reasons we wanted to give you a taste of that today. We think it's very relevant. Jerome also mentioned JPMC. I found this comment from their CIO at Amazon reInvent really stunning. They are actually refactoring 6,000 applications to cloud native. Okay, 6,000. And they truly mean to take advantage of cloud native and do this wholesale. Of course, they have an army of people to be able to do this, including many of them developers, 30,000 plus developers. All right, and then we talked about edge, but this edge to core model really seems to be taking off. Let me give you one tangible example. Factory locations, we understand with manufacturers, obviously they want to have cameras. They are starting to take advantage of enriching that data with things like metadata to be able to track, what types of cameras, what the sensors are. This is really seeming to be a trend that we're starting to get at these days. So let me get at the heart of what we're seeing changing. This trend of using object storage seems to be happening in a few pockets. We start first in the backup space. A lot of the backup vendors started embracing S3, really as a deep tier, something that they viewed as cheap and deep. Now we're starting to hear conversations about how can they optimize more for object storage. We're specifically seeing it now in big data analytics. I'll talk about the example of Micro Focus's Vertica application. Splunk now has what they call Smart Store. One of the big surprises for us is how they're wanting to use object storage in those worlds. Certainly the payloads can be very large, megabyte, gigabyte size payloads for a lot of the data, but it's really turning out to be a mix. I'll talk about an example where we saw Splunk even sending us 1 kilobyte and sub 1 kilobyte type payloads. This has a real change, it has a real impact on the demand of performance that we deliver. Object storage, as you all know it, was classically very good at long-term persistence, long-term storage of large payloads, write once, maybe read a few times. Now we're certainly starting to see much more IO intensive. And the expectation is we can perform, right? It's more random IO, it's lower latency. And for in-memory apps, they just need a lot of throughput to be able to load data very, very quickly to compute on it. A lot of these applications now are starting to deploy on Kubernetes. What are we seeing? We're starting to see the early indications of deployment on Tanzu, of course, a lot on OpenShift, and there are some other environments emerging as well. Okay, but that general trend on performance for object storage demand seems to be the main thrust. We are tracking the standards for how containerized applications on Kubernetes will access and provision object storage. Certainly containerized services can call any kind of storage. They can mount file systems, they can call object storage. We believe the S3 API is great. It's a natural fit for applications that just want to be stateless and call APIs for storage. There is now an effort in the Cloud Native Computing Foundation, the CNCF, to also define a provisioning interface for object storage. You're all familiar with CSI, the Container Storage Interface. They are now finalizing a specification, what is called COSI, the Container Object Storage Interface, for provisioning, automatically provisioning or easier provisioning of buckets inside an object store. That's something we think will emerge late this year or early next year, and we certainly plan to embrace that. Okay, but ultimately we think the model of object storage for these new applications makes a lot of sense. So let me highlight a few of them. I already mentioned Splunk. They have been touting a model they call Smart Store for quite a few years. It's a big change for them. It makes some real big changes in how their compute and their performance gets decoupled from capacity. A big change in how they did that before. Vertica's Eon mode is very similar in that respect and promises kind of the same advantages. And then just to talk a little bit about how Apache Spark can use object storage. But I really want to conclude with some areas of investigation, some new services for how we can optimize data access for object storage. All right, so let's start with Splunk. So Splunk really had a very traditional model of using storage before. It was very tightly coupled. Their indexer tier was tied directly to the capacity tier. Every time you wanted to increase the amount of index resources, you had to scale up the amount of storage on the other side. Smart Store really decouples this. So the index tier now becomes stateless. It really is a cache manager that manages the loading of hot data that it needs to access immediately and tiers that down to warm storage. They are embracing the S3 API now as the interface tier to get to the object storage, and they manage that dynamic movement of data into the cache depending on access patterns. They have made validation of this type of storage very challenging, shall we say. We've been able to work on that with them for single site deployments, replicated deployments, and also stretched kind of synchronous multi-site deployments. So we think this is a real powerful capability and something that gives the user this decoupling advantage. Here's an example of the type of deployments we're seeing, and it kind of ties together these trends that I talked about. It's a big bank. It's a US bank. I unfortunately can't name them yet. We hope to be able to soon. This was a project that was driven by an application team, really to create a data lake inside the bank. And that data lake is for things like fraud detection and threat analysis. So they had to pull in a lot of data sources. Today, the ingest workload is already huge. It's 400 terabytes per day that we get into from Splunk into the object store. They want to keep a full year of that, so 365 days of that retention. This was deployed in this cloud native model. So it's under HPE's GreenLake. It actually uses HPE's Ezmeral container platform. And we are the object store. It was big to start, and it's getting bigger all the time, as you can see with this data rates. We're up to 80 petabytes. It's across 2 sites where they have Apollo servers on site A, several thousand miles away, site B, and we're doing asynchronous replication between them. This kind of environment with Smart Store can support a lot of performance. We're doing 30 gigabyte per second writes, 10 gigabyte per second reads, and ultimately the customer reaps the benefit. If they need to scale up Splunk on the tiering, on the indexing side, they can do that without increasing the capacity. Okay, so that model now we see in other vendors. It's not just Splunk. You can think of Micro Focus Vertica as another analytics platform. Many of you probably have heard about it. And Eon Mode is the very same model. It's essentially using object storage for decoupling, performance of the application and storage as well, using S3. Okay. The last one, and maybe to tie into Giorgio's chat a little bit more, we are starting to see developers using Apache Spark a lot. The classic mode, of course, on-prem has been to use HDFS. We did see the use of object storage for these kind of applications in the cloud, especially in Amazon more and more with services like EMR and Databricks. We are starting to see more deployments of Spark using the S3A connector, which provides object storage access over the S3 protocol, and even with high performance demands, to be able to scale this out and get high aggregate throughput against a large Spark cluster using object storage. So 3 kind of real indications that this seems to be happening in the ISV world. I want to kind of conclude with 3 kind of statements on data access and optimizing it against object storage. There are 2 Amazon services now for providing search against S3. The first one is Athena. The second one is S3 Select. Neither of them are that new. They've been out and talked about for several years now. And then in the object storage space, quite a few vendors, including ourselves, are offering metadata search. So I'll touch on that briefly. So what is Athena? Athena essentially is the use of a relational model to provide SQL access on top of object storage. Okay, so the way it works is that you store your data in S3, in a bucket, in objects. However, what you're doing is formatting the objects to look kind of like a pseudo table. You'll have attributes running across the top with different data types. The objects get formatted as a particular file format, something like a JSON or a CSV. There is also a binary format called Parquet. As long as it's formatted like that, you can provide an external schema view through this external database on top of that and issue SQL queries against the object store. And again, this is across multiple objects. So one object can be 1 or more rows, another object can be 1 or more rows, et cetera. And you can do fairly capable, comprehensive SQL access against this, including things like joins and unions and sorts and things like that. The last few years, there is an alternate model offered in Amazon. It's called S3 Select. This is really the ability to filter on the object storage side. Let's say you format an object as 10,000 rows or 1 million rows within a single object. The idea is rather than transferring the entire object to the application wholesale or through a byte range type operation, instead you can say, I'd like to filter based on some row, some attribute criteria, select the attributes where the ID is 1, for example. So this is quite capable. However, it's not doing index searches, it's doing scans. And we find that this offers a little more limited or quite a bit more limited SQL access. But nevertheless, there are these 2 models. In the object storage space, what we've done and what we've invested in along with other vendors is to really provide enrichment of metadata. So most of you know that S3 not only provides the data access, object puts and gets, but it also provides the ability to extend metadata. So you can add attribute value pairs on all your objects. For example, the example I show here is adding a study ID and a study location on an object and storing that. Metadata search is the ability to provide access to that based on attribute values. So essentially I say, get my objects from this bucket, but filter based on a criteria, such as a location. It can be an index search. It can be an optimized search. And in that case, we return only the objects that match the search condition. So it really can help accelerate and simplify the application as well. So that's it. Those are kind of the 3 things I wanted to state. We're really seeing a change in the world of applications, especially AI, ML, in terms of how they're deployed more and more on Kubernetes and how they're optimizing and embracing object storage. So that's it. Thank you very much.
So I think we're going to be good on time. I'm going to do a demo where basically look at deep learning workflow, like somebody would do, trying to build a model and to test it. And everything will be stored in an object storage. I'm going to be using ARTESCA. And there's some benefits to doing that, and I will explain as we go along. So this is kind of, there's no security blanket in this demo. It's all live, and everything is running on servers, VMs in our on cloud, and a deep learning server that's running in my living room. So that's kind of there's a few moving parts, but you see. And this is using Jupyter. It's a notebook that's very common when you do AI, where you basically can go through all your code in a graphical, like in a user-friendly kind of way. So I'm going to go through the different steps. So I'm importing some of the libraries that I'm going to use for this. This is based on research by NVIDIA, where they worked on a lot of pictures of people, a lot of faces, and they try to build a model where you give it a point in space and it gives you a realistic face of somebody. That model basically can generate faces of people that do not exist. And some of the work that has been done is the opposite. Based on a picture of somebody, can you find the point that will generate that person? And that's what we're going to play with today. So just some context. So we have a physical node that's running a TensorFlow. I can connect to it right here. So in that environment, I have one card that we're going to use. And that's the heavy lifting in that demo. In terms of storage, there's actually very little storage on that particular environment, where it's mostly full. And the 90 gigs or so that are being used are coming from all the libraries. These libraries are huge to get this going. So I have very limited space, which makes sense because when you do this kind of things, you're going to have 1,000 compute nodes. And they all are pretty much stateless. So they don't maintain a state, so we don't need storage. For this example, I'm going to use ARTESCA as my single source of truth. And if I had more than one compute node, they will all be pointing to the same ARTESCA. So let me walk around the UI. So it's actually running in a virtual machine. We still were able to generate, to create volumes and having a virtual disk for the demo. It's currently storing around 50 gigabytes. So I have my S3 service. ARTESCA runs on top of Kubernetes, but as you will see in the demo, the user doesn't need to know. It's all using our own UI, and we use Kubernetes as an API in the backend. So this is kind of what we give the end user as the view of the actual service. So there's one node, which is the ARTESCA VM that I'm using. There's all kind of metrics and information. I can zoom in on that node. I don't have to connect to the actual Kubernetes cluster. To run ARTESCA, it's a combination of our S3 API, our multi-cloud technology, and our metadata engines. So you see a lot of volumes that are being used. So the storage volumes, we call it HD, as well as key management, volume management, alerting with Prometheus. All of that is self-contained. In terms of volume, you can zoom in on any of the attached volume in our system. That's a whole block device, 10 gig. So I have 10 gigs storage volumes to have an aggregate of 100 gigabytes. And I'm doing erasure coding on the different volumes in the system. Based on all this, we create a storage service, and I can log in and look at the cluster stats, number of versions per second. It's kind of reloading a bit, but it should be okay. And at a glance, I can see all the response code from the system. I can see that things are working properly. And let me click on this one. If I had more than one node, I would see each of the nodes listed here to be able to zoom into them. All of that is put together to contribute to the S3 interface, where we give the users the ability to manage the system as if it was a cloud, with creating accounts, creating access keys, giving rights, all that what you would imagine building a cloud. In terms of multi-cloud services, We support all the features in ARTESCA that Zenko supports as well in terms of multi-cloud support. So Amazon, Azure, all kind of different services, Google, as well as the workflow for replication, transition, lifecycle. So if I wanted to connect to another cloud, I will do it to a new location, and here I will name it. And here you see all the different location that we will support. So Amazon, Ceph, DigitalOcean, Google, Microsoft. NFS mount is a pretty interesting one if you want to mount existing storage like an Isilon or a NetApp. And then you will access it via the S3 API. All the different Scality storage product and Wasabi as a cloud service, and also the local file system is the target as well. So you would basically come and register all your different clouds to be able to use them. Let's go on the demo side. So I have this ARTESCA module I'm importing. That's a standard S3 access module. I'm just doing all the authentication first, so we don't have to see all of that. In my object store, I have one bucket called StyleGAN, and inside of it, I have all my data. So if I go into the data browser over here, so that's my bucket. Models is the actual model that's already pre-computed that can generate realistic faces. And I have two of them, two different versions. And then I have this folder latent representation, which is basically points that give me the people that I want to work with in the demo. So I'm going to load the model. So that's loading from the object store. There's nothing stored locally on the machine. So there's some verbosity into the loading of TensorFlow, but that's done. Now I'm going to load some code just to show some of the images. So to test that the model is working, I'm going to ask it to generate random faces. So let's wait. It's actually pretty fast. So I can call that many times. And it's actually generating realistic faces of persons that do not exist. Now these people are just pure random numbers. So based on that, I worked, or actually the computer worked last night to extract from pictures what point will generate the exact same face into that system. If you want to have a really realistic thing, you have to run for a few days per picture, and this ran for maybe 1 hour per face. Some people worked on finding some vectors into the space where if you move into that direction, you're going to change the faces. So like you can smile more, change gender, change age. So I'm just loading this existing vectors. And just so we know, on the right, you have the original image, then what the model was able to derive as a representation in that virtual space. And it's pretty accurate. If you were to run for longer, you would see something even more striking. So now that I have my vectors, my models, everything's loaded, I can play with it and kind of change us and add some smiles to the faces, but just by moving into that latent space.
Very scary.
And so if I were to do some research, I will try to find a point that's interesting. So maybe I'll move in a gender direction. And you see me, Paul, and Jerome being morphed. And I can decide to kind of continue searching and maybe look for a point that I think. Yeah. And I could look for a point that I think.
Woman.
Yeah.
The one on the left, Jerome, you really don't look bad.
But I don't think he would like to hear.
Yeah.
No man wants to hear.
Yeah, but come on. Giorgio, Paul, you're the only one who is much better off as a man, I must say.
Thank you for that. Yeah, there's an Angela Merkel somewhere in there.
You can't you can't take this as a compliment or any other way because it's just.
Well, what have you got against our Chancellor?
Nothing
I'm
against
not
her.
listening.
Sometimes technology can be really good fun, can't it? Look at that. Let's screenshot that, shall we? There we go.
You want to do that now? Okay.
There we go.
No web postings, Fred.
It's gonna use the internet.
All right. Let's carry on, Giorgio, but thank you so
Okay.
much. This is the best demo.
That was always the fun part of the demo. So now we're going to play a little bit more to kind of find a new face that will make sense. So you see we can do arithmetics on faces. So we can do Paul with Jerome divided by 2. We can do things like moving from one to the other. So this is what happens when you do this. So you see the morphing of the different faces. And I took the average of Jerome and Paul over here and morph it to me. So that kind of give us, maybe I have a data point over here that I want to share with other scientists, because I think it's a pretty interesting thing. So let's zoom on that one and show this. So that's the mix of all three of us. So based on that, I may want to share it with other people because it's such a unique data point. And I'm going to push it back to the object store. So far, the storage server didn't store anything. To push it to the object store, I'm going to have to save that and then put the object back into my ARTESCA instance. So that's what I did. I'm adding some metadata to it because in truth, I may have millions of different data points. And with metadata, you will see that I can search and quickly locate it on ARTESCA. One thing that's built into object storage is the ability to do a collaboration where I can give a link to anybody, even if they don't have an account, and they'll be able to download and access whatever I give them, just like a Dropbox, but without having to deploy anything special. It's all built into object storage. So I'm going to create this link over here. So if I were to give that link to anybody, they can download this data point that I just created without having to get any special access into the system. And this will expire automatically after 1 hour, and you can put any value that you want. So if I go back to the ARTESCA UI and on this side, so now some of what Paul talked about metadata search, I just wanted to show a little bit what you can do. So there's different models into the system. If I wanted to get the latest version, I can just do a search for all the object with a tag revision that has the value latest. That gives me the latest model. So these are the kind of things you can do in object storage, and that search across the entire bucket. If I wanted to look for keys that are kind of latent vectors representation, I can just look for keys with that suffix and find them. It's pretty fast because it's all pre-indexed, this kind of searches in our system. I can also look for that host I was on. When I generated this data point, I actually added the host name, host ID as part of it. So this way I know which machine generated what. And so the metadata search is finding that VIP point, but we just uploaded into the system based on this metadata search. And now I can download it and use it for anything I wanted to do. I can also do arbitrary searches on any of the system metadata. It could be content len. So let's find all the big, large objects to the system, and it finds the models because they are the biggest objects into the system. Since this is based on all our multi-cloud technology, I can also go into workflows and start thinking about replication to another cloud. So I have this bucket that we work with, StyleGAN. Hopefully I can select it. This is where the demo effect comes in. Not at the deep learning part. Okay, and I can select a destination. So we have 2 AWS destination over here. So for some reason I can't select it, so I will not select it. I will be able to create a policy to replicate or to transition data into a different storage location. So that's for the overview of ARTESCA. Do you have questions, or otherwise I go back to the deep learning? There's a few more faces we can look at.
Yeah. Brian, is it all clear? Because I know you're one of our more technically interested influencers. Where is he? Have we lost Brian?
No, I'm
good?
following on. I'm probably ready for my next cup of tea, actually.
Okay, fair enough, fair enough. No. It's been a long day. Okay, well, Giorgio, back to you then with the next section.
Yeah, so I didn't do all the faces that you sent me, but I took 3 of them, and I did the work of finding the actual virtual version. So we have Chris, Enrico, and Randy over here, and we can do all kind of the same transformation that I was showing earlier, and go into all these different models. Well, we can actually go both ways. So we're going more female on the left and more male on the right. So we can some things interesting happen. So this only went for a few minutes, so we will need to run longer to get a more realistic one. But I think it's already
one or two of these are quite scary.
Yeah.
I must say, Tony, you're right.
Yeah, more than a little bit.
Sorry, Giorgio. I've just got a quick question.
This is Kimberly. Can you send me the ones with Randy? I'm sure the rest of the group.
The teeth on the 1.5 smiles are scary too.
Yeah, it's a little bit scary. Yeah.
Giorgio,
I don't think you need to send the scary Chris
Simon.
ones out.
Sorry, Tony. Simon has asked, are you able to share the Jupyter notebook?
Yeah, I can share it. Yeah.
One thing I've found interesting through the demo and the conversation is, just we were already seeing it, but it's great to see this confirmation here that object storage is broadening its applicability, the range of applications and use cases. Do you want to have a go at projecting what's next? What's it not being used for yet that you think it will do next, for instance?
Yeah, I think we're definitely seeing faster movement in some categories of applications. I think the slower moving ones are probably the industry specific ones. We deal a lot with like healthcare. Certainly healthcare records they're database oriented, so it's not a fit. Healthcare imaging has been very classically file-based workflows and kind of stuck to that. We're starting to see a few of the vendors thinking about it. They tend to be a little slower. I think in media and entertainment, it's a split. A lot of the tools for producing content are file-based, but they're starting to use object storage for content distribution. So that seems to be a transition point. But I think we see a lot of embrace of it in the data protection space. Vendors like Veeam and Commvault, and they're really jumping on it.
That's one of these sort of the current kicks, isn't it? Yeah,
it really seems to be. Yeah, so it's been interesting for us because over the 10 years, we've had rises and falls of people talking about embracing object storage. I think we're at a real high point, right? And it's these ISVs thinking that mainstream business applications can use it in a more primary way.
When you say high point, you mean rate of adoption rather than...
Yeah, rate of adoption, and moreover, if you go and talk to them about their roadmaps for embracing it in a more primary way, they're thinking about that much more predominantly now than ever.
Okay, thanks.
Sure.
Giorgio, while we still have some time, do you want to create some more of the audience pictures?
Also, to generate the points, it takes a little bit of time, so I'll do that offline.
Oh, okay. Yeah. Right. Anyone else have any questions?
I have one, which is when it comes to object storage, I'm just intrigued in its relationship to the way that edge computing will create a dispersed data center environment, and a lot of the data, therefore, doesn't necessarily have to move from where it has been created. It's going to be processed in the area that it's created. And so what needs to come back to anywhere central is just something like metadata about that data, where it's located, roughly what it is, Do you see that being a key role for object storage in the future? And that, so you're actually reducing and containing the amount of data that actually moves around.
Yeah, I think we see the storage very integral with the compute, with the application in that perspective. I mean, we've all heard the famous use cases of autonomous vehicles needing to capture sensor and video data. Clearly, they're not going to send all the video. You know, we heard one study, what was it, from Toyota in Japan, running a pilot project with just taxi cabs in Tokyo. That was already generating something like 15 petabytes per week of video data. There's clearly no need to send that all. Filtering is going to happen, and we're starting to think about policies that can help, you know, provide rules for how the data is filtered. Today, we support simple things, right? Replicate my data or lifecycle my data. It fits things, but people really want to insert custom logic into that, and I think it goes hand in hand with your statement around needing to filter the data before it goes anywhere else.
I was just going to ask a supplementary. Any estimate of when such policies might be available?
I think this is the kind of, you know, research that needs a use case from a particular customer to really help guide it. I think one of the areas that will really be tangible sooner is this data sovereignty world. That's, I would say, the main thing we're hearing is rules for location control and location enforcement, you know, for things like GDPR and sovereignty. That seems to be the tangible next one. But I would also say we're hearing very specific requirements in domains like healthcare, you know, privacy regulations on data. So rules around that. So, you know, I think that's the driver, is some specific need.
And presumably ownership. One of the things I've heard from insurance industry people concerns the fact that the automotive manufacturers, their vehicles are generating huge amounts of data, but they are refusing to let it out.
Okay, I left the gate open for
to leave it so that let the insurance companies have that data so that they can set flexible policies for their customers, but the car manufacturers won't let anybody have that data.
Yeah, I think you're pointing out something, that the rules are so custom across the board. I mean, when we started this journey to give multi-cloud data management, we must have heard 36 different types of use cases, right? A few things emerged pretty clearly. What people needed was a way to archive data once it became older, a way to move data to a processing element or processing service, and then a need to keep a secondary copy of data. Those are kind of tried and true, and they seem to be pretty horizontal. After that, you get, you know, 15 different variations of everything. And what everybody says is, just give me a way to decide what the data movement rule is by introducing my own logic. That seems to be the common ask. So that's the kind of research we're working on. But to answer your question about when, it gets driven more by specific customer needs.
Yeah.
And I think right now we're hearing more healthcare, you know, healthcare and GDPR type things.